Hello friends, pull up any CPU listing online and you will see something like this. AMD Ryzen 7 9800X3D, 8 cores, 16 threads, Zen 5 architecture. Those three numbers show up on every processor spec sheet. Whether you are shopping for a gaming rig, a workstation, or just trying to figure out why one chip costs twice as much as another. But what do they actually mean for real-world performance? In this video, we are going to break all three down clearly, one at a time, using real chips as our examples so you walk away knowing exactly how to read any CPU spec sheet with confidence. Let us start with the first number, cores. Alright, let us start with cores. A CPU core is an independent processing unit inside the chip. It can fetch instructions, decode them, execute them, and write results back, all on its own. Think of it like chefs in a kitchen. One chef can only plate one dish at a time. But if you have 8 chefs, you can plate 8 dishes simultaneously. That is exactly what more cores do for your computer. Consumer chips today range from 6 cores, like the Ryzen 5 9600X, all the way up to 24 cores on Intel's Core Ultra 9285K. And on the server side, AMD's EPYC chips pack 128 cores into a single processor. More cores means more tasks handled in parallel, which is why video editors and 3D artists love high core count chips. Now, cores are only half the picture. Let me show you threads. Now let us talk about threads. A thread is a single stream of instructions that a core is actively executing. Here is the interesting part. Some cores can handle 2 threads at once by switching between them so fast it looks simultaneous. AMD calls this simultaneous multithreading, or SMT. So the Ryzen 9 9950X has 16 physical cores, and with SMT, each core runs 2 threads, giving you 32 threads total. Intel took a different direction with its Arrow Lake generation. The Core Ultra 9285K has 24 cores and 24 threads, because Intel dropped hyperthreading entirely from that design, deciding the saved power and complexity were worth the trade-off. Neither approach is wrong. They just reflect different architectural philosophies. But to understand why those choices were made, we need to look at what a generation actually means. Let me explain that next. So what exactly is a CPU generation? A generation is a full architectural redesign. It is not just a faster clock speed. It means a new microarchitecture, a newer manufacturing process node, and a new set of platform features. Take AMD's Ryzen 9000 series. It uses the Zen 5 microarchitecture, built on TSMC's 4 nanometers N4P node, and delivers a 16% uplift in IPC, meaning each clock cycle does 16% more useful work than Zen 4. Intel's Arrow Lake uses new Lion Cove performance cores and Skymont efficiency cores, built on TSMC's 3 nanometers N3B node for the compute tile, with about a 9% IPC gain over Raptor Lake. Both generations also introduced platform upgrades, DDR5 memory, and PCIe 5.0 connectivity. So a newer generation chip often beats an older one even at the same clock speed, simply because each cycle is more productive. That matters enormously in practice, as our next example will prove. Here is where it all clicks together. The Ryzen 7 9800X3D has only 8 cores and 16 threads. The Intel Core Ultra 9285K has 24 cores and 24 threads. By raw count alone, you would expect Intel to win in gaming, but benchmarks from Tom's Hardware show the 9800X3D leading by around 35% on average across gaming tests. How? Generational innovation. AMD's 9800X3D stacks an extra 64 megabytes of cache directly on the chip die using 3DV cache technology, bringing total L3 cache to 96 megabytes. Games are latency sensitive. They hammer the cache constantly. That massive on-chip cache dramatically reduces how often the processor has to wait for data from slower system memory. The result, the 8-core chip smokes the 24-core chip in gaming. Raw core count lost to architectural innovation. Generation and design matter as much as the numbers on the spec sheet. Alright, let us bring this all together. Every time you look at a CPU spec sheet, run through 3 quick questions. First, how many cores? More cores means more tasks handled at the same time, which matters for content creation, servers, and heavy multitasking. Second, how many threads? Check whether the chip uses SMT for 2 threads per core, or maps 1 thread to 1 core like Arrow Lake does. Third, what generation and architecture? A newer generation means higher IPC, a more refined process node, and updated platform features like DDR5 and PCIe 5.0. The Ryzen 7 9800X3D taught us that a well-architected 8-core chip can outperform a 24-core chip in gaming. Cores plus threads plus generation gives you the full picture. Thanks for watching, and we will see you in the next one.